For the network shown in the figure without CE, that is unbypassed, determine RE, ZI, that is input impedance, output impedance and voltage gain. Okay, so by seeing the figure, you know that it is an emitter bias and what configuration? CE configuration. So you can write that it is a CE configuration and emitter bias circuit. And from the problem, you know that you have to find out, or it's an RE model. So step 1, we can draw the RE model of emitter bias circuit. So how will you draw the RE model of emitter bias circuit? Okay, so first you are going to replace the transistor by means of its equivalent RE model. So you know that the input side will be have a resistance of beta Re, and the output side it will be a parallel combination of a current source with that of a output impedance R0, right? So what will be this point? It's emitter, input is your base and output is your collector. So this will be your transistor's equivalent Re model, right? Now to this you are going to add the different other parameters. So you have a resistor across the emitter. So here you will be having an emitter resistance, that is Re. Across the input you have a base resistor, that is your RB. I am connecting it to the ground, RB, right? Across the what collector you have your resistance RC. So across the collector you have your resistance RC. I hope that since we have done a lot of problems, you know how to convert it into an RE model. The basic steps remains the same. So this will be your input and here you will be getting the output, right? Plus minus, and here it is plus minus. So what will be your input impedance and output impedance? So looking towards the circuit from the input side, here you have Zi. So in the derivation you are going to take, looking towards your transistor, you can take it as the impedance as ZB. Similarly from the output it will be your Z0, right? What will be the emitter current? I can write it as beta plus 1 into IB. So this is in short the RE equivalent model of the emitter bias circuit. So now I'm going to write what are the formulas initially. So step 2, we can write the formula so that it will be easy for you to do the calculation. So what will be your RE? RE is equal to 26 millivolt divided by IE. What will be the next parameter? Input impedance. Input impedance will be equal to, you have to take the effect of R0 also, because R0 is given as 40 kilo ohm. So what will be your input impedance Zi? Zi will be equal to RB parallel to ZB, that is capital RB parallel to ZB. So what will be your value for ZB in the case of R0, including your R0. So including your R0, you know that ZB is equal to beta into RE plus capital RE under the condition R0 is greater than or equal to 10 times of RC plus RE. Okay, so this will give your ZI. Okay, now next one is your output impedance. For any value for R0, what will be your output impedance? Which will be equal to RC. And D part, so here also including your R0, what is the value for your gain? That is AV is equal to, what is your value? Minus beta into RC divided by ZB under the condition, what will be your condition? Under the condition R0 is greater than or equal to 10 times of RC. So these are the different formulas you have to substitute in order to get the answer. Okay. So first let us do the A part. So if you want to find out the A part, you know that R is equal to 26 millivolt divided by IE. So if you want to find out the value for IE, what you have to do, you have to proceed with the DC analysis. So what will be your DC analysis of emitter bias configuration? When you apply the input loop equation, from this you have to calculate the value for IB, right? KVL. when you apply KVL across the input loop. So you know that IB will be equal to VCC minus VBE divided by RB plus beta plus 1 into RE. Right. So what will be your values now? Can we substitute the value? What is your VCC? VCC is equal to 20 volt minus VB is equal to 0.7 divided by what is your RB? RB is equal to 470 kilo ohm plus what is your beta? 120. So 120 plus 1, it is 121 into what is your RE? RE is equal to 0.56 kilo ohm. Okay. So after solving, what you will be getting? 20 minus 0.7, you will be getting 19.3 divided by 470 kilo ohm plus 67.2 kilo ohm. Okay. So after solving for 470 plus 67, you will be getting, which is equal to 19.3 divided by 537.2 into 10 raised to 3. So you will be getting, finally the answer will be IB is equal to 35.9 microampere. So now you have got the value for IB. So once you have calculated the value for IB, can you calculate what is IE? What is the relationship between IB and IE? IE is equal to, you know that, beta plus 1 into IB. So beta is equal to 120. 120 plus 1, it is 121 into 35.9 microampere. So when you calculate it, what will be your value? You will be getting it as 4.34 milliampere. So now you have got the value for IE. So you have got IE, so you can substitute in the main formula, which is equal to RE is equal to 26 millivolt divided by 5.34 milliampere. That is, RE is equal to, after calculation, you will be getting exactly as 5.99 ohm. Okay. So the first value you have obtained. Now B part. B part, you have to find out what is your input impedance. So I have told you already what is your input impedance, Zi, which will be equal to RB parallel to ZB. But what is your ZB in the case of including R0, right? Including R0, ZB is equal to beta into RE plus capital RE. Under the condition, what is the condition? You have to check R0 is greater than or equal to 10 times of RC plus RE. So let us first check the condition whether it is satisfying. R0 is greater than or equal to 10 times of what is your RC? RC is equal to 2.2 kilo ohm plus what is your RE? 0.56 kilo ohm. So what is your R0? R0 is given in the question as 40 kilo ohm. So 40 kilo ohm is greater than or equal to, what is the value you are getting? 2.10 into, you will be getting 2.76 kilo ohm. So 40 kilo ohm will be greater than or equal to 27.6 kilo ohm. Yes, 40 is greater than 26.6. It is satisfied. Okay, condition is satisfied, so that you can proceed with the calculation. So now we can calculate what is your ZB. ZB is equal to beta into RE plus capital RE. So what is your beta? Beta is equal to 120. 120 is what is your RE? RE is equal to 5.99 ohm plus what is your capital RE? 0.56 kilo ohm. Okay. So you will be getting ZB is equal to 67.918 kilo ohm. Okay, so here you will be getting it as kilo ohm. So ZB you have calculated. Now can you apply in the formula? What is your Zi? Zi is equal to RB parallel to ZB. So Zi is equal to, what is your RB? RB is equal to 470 kilo ohm. 470 kilo ohm parallel to what is your ZB? 67.918 kilo ohm. So I can write Zi is equal to 470 kilo ohm into 67.918 kilo ohm divided by 470 kilo ohm plus 67.918 kilo ohm. Okay, so what will be your answer? So you will be getting nearer to 3100 and oh sorry, not 31,921.46, okay, into 10 raised to 6 divided by 537.34 into 10 raised to 3. So this will get cancelled. So you will be getting Zi will be equal to 59.34 into 10 raised to 3. So it will be kilo. So Zi is equal to 59.34 kilo. You have got the answer. Now what will be your Z naught? Z naught will be, you know that C part, right? Z naught will be approximately equal to RC. So RC is equal to what is the value? 2.2 kilo. Finally, the D part, you have to find out what is your voltage gain. You know that including R naught, the voltage gain is given by the equation minus beta RC divided by ZB. So minus, what is your beta? Beta is equal to minus 120 into RC is equal to 2.2 kilo ohm divided by what is your ZB? You have calculated 67.918, right? Kilo ohm. So after solving, you will be getting AB is equal to minus 3.887. So you have got the first one, RE is equal to 5.99 ohm. Okay, RE is equal to 5.99 ohm. Then you have got RE. Second one, you have got B part, you have got ZI is equal to RB parallel to Z. RB parallel to ZB, you have got 59.34 kilo ohm, and Z0 you have got 2.2 kilo ohm, and your AV is equal to minus 3.887. Okay, so these are the values which you have got.